now we look at almost the same equation as in the preceding, but this time, instead of cosine of 3t, we've got cosine of 2t. Now, if we try to put a multiple cosine of 2t into our trial solution for the particular solution, well, you probably remember that cosine of 2t was a solution to the homogeneous equation. So any multiple cosine of 2t we want to put in our particular solution is going to give us 0 when we put it here, and we're never going to get our cosine of 2t. Now, excuse me for a minute, I had to pull the door to a little bit. Some people out in the hall, they're not being bad, but things get a little busier this time of the day, so take a precaution. Okay. So what are we going to do when we set up our trial solution? Now, first place, let's be clear that our characteristic solution, our solution to the homogeneous equation, is just what it was before, and I'm not going to rewrite that. We want to concentrate on what we need to do to get our particular solution. Okay, well, the e to the t part is going to be easy. Our particular solution is going to have a constant times e to the t. But we can't use cosine of 2t. What do we do? Well, if you understand reduction of order, you'll understand why. But in most cases, it turns out that we can get around this by just putting a t in front of the cosine of 2t. Now, we're trying to get a cosine. We can also take derivatives of t sine of 2t to get cosines, right? So we're going to have to use this as well because we have to cover all possible bases. And there are more formal reasons for that, but that's the way it kind of feels. So our particular solution is going to be c1t cosine of 2t plus c2t sine of 2t plus c3 e to the t. Okay, now it's just a matter of taking some derivatives, plugging in, and solving for our constants. And it's not that bad, but you do have to keep your wits about you. And primarily, you've got to be really careful taking your derivatives, make sure they're all right, and really watch your bookkeeping, which is my challenge. And the older I get, the less I seem to be able to do about that. Taking the derivatives is not a problem, but keeping everything straight and organized on the page, especially when I have a small board. No excuse. Just telling you, try to be very organized about the way you write these things down because it saves you a lot of pain. Okay, well, what's our derivative of yp? Okay, well, derivative of yp, let's take the derivative of t cosine of 2t. It's product rule, derivative of t times the cosine of 2t plus t times the derivative of cosine of 2t. Now, I'm not going to go through the details, just reminding you. And of course, the cosine of 2t, when you have to take its derivative, you're going to have to use a chain rule. You're going to get a factor of 2. Okay, well then, on c1, you're going to have what? Just a cosine of 2t. When you take the derivative of t, you get a 1. And then it's going to be c1t times the derivative of this. The derivative of this is negative 2 sine of 2t, and that's where this term comes from. And you get similar terms for the c2t sine of 2t. And the c3 e to the t, that one's really easy. I didn't put a coefficient on the t because I wanted to be gentle, okay? But that would have been no problem. You just keep your wits about you, write things down carefully, and it all works out. Okay, so the second derivative, well, we got to take the derivative of all of these things. Well, here it is. Okay, I'm not going to point. And here it is where I've isolated the sine of 2t terms. There's one here, and one here. That is, we're seeing that we have the same coefficient on both of these sine of 2t terms, negative 2c1, negative 2c1. Here we've got the negative 4c2t. And on the cosine, we have something similar. And of course, we still have to have our exponential. So what we get then ends up being, well, negative 2c1 is negative 4c1. I thought I saw something there that disturbed me for a minute, but I didn't. I did imagine something that disturbed me, but it wasn't there. Okay, so negative 4c1 minus 4c2t on the sine of 2t, you know, 2c2 and 2c2 gives us 4c2. We got the minus 4c1t. And the cosine of 2t. And we seek a symmetry between these two. And you know, maybe want to think about that a little. Did that really come out right? Is that the way it ought to look? Just to double check ourselves. And then we got the c3 e to the t. And then we plug that into the equation. Okay, we have this second derivative plus 4 times our original y function. Now, that's the way it comes out. This is what the left-hand side is going to be. And here's our right-hand side. Well, we collect all the terms here on the cosine of 2t, and conveniently, the negative 4c1t and the positive 4c1t divide out. So we only end up with our 4c2 times cosine of 2t here, and that's got to equal the cosine of 2t. So 4c2 has to equal 1, c2 is 1/4. You easily enough conclude that c2 has to equal 0. I'm sorry, c2 is 1/4 and c1 is equal to 0. Write it down, you'll get it. And the e to the t works out just as it did before. So we have now our general solution. Our a cosine of 2t plus phi, the form in which I chose to put the solution to the homogeneous equation, and then 1/4 t sine of 2t plus 1/5 e to the t. Okay. Now there's another way we could have solved this equation. We could have found our particular solution using variation of parameters. So to further illustrate variation of parameters, we're going to do that on the next video clip.